So good morning, friends. We'll start SMPCC 2 2018, Article 210. In-service welding onto carbon steel pressure components or pipelines. So welding onto pressure components or pipelines with thin walls, 4.8 millimeter, 0.188 inch or less, is possible as long as precautions are taken. Such precautions include controlling the heat input or penetration of the welding process using smaller diameter electrodes, 2.4 mm, 0.094 inch. When the wall thickness is less than 6.4 mm, 0.25 inch, safety aspects and a contingency plans aspect for the occurrence of burn through should be planned for in accordance with company practices, industry standards, API recommended practice 2201 or post-construction code. Tensile stresses can also always be assumed due to the shrinkage of the weld upon cooling. Hydrogen typically cannot be eliminated but can be reduced by using proper low hydrogen welding process such as shielded metal arc welding with the EXX18, EXX15 type electrodes. Crack susceptible microstructure typically have high microstructure hardness and are controlled by carbon equivalence of the material and the rate at which the weld cools. The most common in-service welding practices used to reduce hydrogen cracking occurrences incorporate both low hydrogen welding process and welding procedure that reduce the susceptibility of forming a crack-susceptible microstructure. The use of preheat is another technique that is commonly used to reduce the susceptibility of forming a crack-susceptible microstructure, but it may be difficult to apply in service welding applications. Because the ability of pressure component of pipeline contents to cool the pipe well, especially for the thin walled application. For example, when welding onto a pipeline less than 6.4, 0.250 inch thick, it may be necessary to reduce the welding heat input to lower the probability of burn through. However, the lower welding heat input could result in weld microstructure that is susceptible to hydrogen cracking. When the maximum required welding heat input to eliminate the probability of burn through is lower than the minimum required heat input to protect against hydrogen cracking. Then alternative precautions need to be taken. Welding procedure that included a temper bead deposition sequence. Limitations, piping and pipeline modification, pressure component, pipeline components, operating pressure. So that is the problem burn through. Safety aspect, contingency plans you have to take. Owners shall evaluate the effect of in-service welding. Combustion, explosion, increased susceptibility or to corrosion, embrittlement. So he has to look for that. Then adjustment to flow during the service welding may be increased hydrogen cracking risk, increased flow or burn through risk, reduced flow, burn through risk when reduced flow and hydrogen cracking and increased flow. An adjustment in the flow should be addressed prior to the service welding. Post-weld heat treatment, PWST. PWST is difficult to perform when pressure component or pipeline system remains in service. Design in accordance with application construction code or post-construction code. If the attachment provides adequate reinforcement in accordance with the applicable construction code or post-construction code, no further reinforcement is required. If the attachment doesn't provide adequate reinforcement in accordance with an applicable construction code or post-construction code, additional reinforcement is required. The weld metal buildup shall be designed in accordance with the applicable construction code or post-construction code. Fabrication welding procedures shall be qualified using setup outline in mandatory Appendix 210.1, 210.4.2. Essential variables of the welding procedure qualification shall be in accordance with applicable construction code or post-construction code and should include the in-service welding essential variables listed in 210.4-11. Warning: material that have high carbon equivalent value greater than 0.45 or experience severe weld cooling rates, high cooling potential may require special precautions such precautions may include but are not limited to temper bead welding sequence or applying a preheat step prior to in-service welding. In-service fillet weld, in-service attachment weld, in-service weld metal buildup. The rate at which a weld cools or cooling potential is an essential variable. Cooling time from 800 degrees centigrade to 500 degrees centigrade. 1472 degrees Fahrenheit to 932 degrees Fahrenheit. Or cooling rates 556 degrees centigrade. 1000 degrees Fahrenheit. Per second. An increase in the cooling potential of the in-service pressure component or pipeline greater than the cooling potential used during the qualification of the welding procedure requires requalification. Is the carbon equivalent formula C equal to C plus Mn by 6 plus chrome moly vanadium by 5 nickel plus copper by 15. Welding consumable. An increase in the diffusible hydrogen level of welding consumable or a change in electrode type defined in SME BPVC section 9 QW 432 or another applicable construction code or post-construction code. Heat input. An increase in heat input over the range specified in service procedure qualification or specified in the service welding procedure shall be evaluated experimentally by computer simulation or combination of the method. A decrease in heat input below the range specified in service procedure qualification specified in service welding procedure shall require requalification to determine the probability of hydrogen cracking susceptibility. Hydrogen cracking susceptibility should be evaluated using the test outlined in para 210.4.2. Welding current. A change in range of welding current used to procedure qualification specified in the welding procedure shall require requalification. So type and number of test specimens required for service welding procedure qualification less than 12.7. Fillet unit 4 phase bend 4 nick break, metallography 2, hardness 2. Attachment hairsband 4, nick break 4, metallography 2, hardness 2. Weld metal buildup 4, metallography 2, hardness 2. Greater than 12.7, fillet hairsband 4, nick break 4, metallography 2, hardness 2. And then attachment, if it is that, then it is hairsband 4, nick break 4, metallography 2, hardness 2. Weld metal buildup, hairsband 2, sideband 2. No need nick break, metallography 2, and hardness 2. Post-weld backout, reduction of the temperature at the time of application of a post-weld backout shall require requalification. Any potential effect on post-weld backout has on the pressure component of pipeline content shall be evaluated. So preheat, any potential effect of preheat requirement has on the pressure component or pipeline content shall be evaluated. Hydrogen backout, a change in the temperature or time of applications of the hydrogen backout procedures shall require requalification. The welding procedures shall be qualified using setup outlined by mandatory appendix 210.1, 210.4-2. The essential variable for welding procedure qualification shall be in accordance with applicable construction code or post-construction code and should include the in-service welding essential variable listed in para 210.4-1-1. Destructive test method. In-service welding procedures test samples shall be taken from the procedure qualification weld coupons as specified in para 210.4.2.2. The procedure shall be qualified by successful completion of test specified in paras 210.4.2-1-1 4.2.1.1 through 210.4.2.1.4. The number of tests for each in-service welding procedure given in the table 210.4.2. Already we see 2.1-1 2 procedure qualification weld coupons should be fabricated if there is not enough material available for all the test samples in one procedure qualification. The destructive test specimens shall be machined in accordance with AWS B 4.0 or other applicable standard. Macro section test, complete fusion, no crack, no undercut exceeding 0.8 mm, 0.031 or 10% of the simulated in-service pressure component or pipeline wall thickness, whichever is smaller. The fillet welding procedure only, the fillet weld leg length are at least equal to the leg length specified in the welding procedure or other applicable process control document. Hardness test. With ASTM E384, a minimum of 5 Vickers harness indents using 10 kg load shall be made to the coarse grained heat affected zone of the weld toe in accordance with figure 210.4.2.1.2-1. The macro section test samples may be used for the hardness test samples after the metallographic analysis has been completed. Nick break test. Nick break test samples shall be removed and machined using non-thermal method and shall be tested according to AWS B 4.1 or another equivalent document. Complete fusion, no single pore exceed 1.6 mm in size and combined area of all pores doesn't exceed 2% of exposed fraction surface area. No slag inclusion exceeds 0.8 mm. 0.031 inch in depth and 3.2 mm, 0.125 inch, or one half the nominal pipe wall thickness of the length. Whichever one is smaller, the distance between the adjacent slag inclusion shall not be less than 12.7 millimeter, 0.5 inch. SI as defined in AWS 3.0 should not be cause of rejection. Face or sideband test, AWS B 4.1. The bend test samples should be bent in guided bend test, jig or equivalent equipment. For face bends, the bend test samples shall placed with the face or weld opposite to the mandrel, figure 210 4.2 1.4. Okay, let us see the figure. That is the figure, and once slightly one-sided, because if you see here, it is slightly center is at the end in hatch zone. Typically in service pilot weld. Then you have this test sample location in service. Nick brake face bend, or if it is pipe, this is face bend nick brake and face bend nick brake. Attachment weld, pipe. NB the nick brake test sample, FB the face bend sample, MS is the metallographic test sample, and auto scale. Okay, the visual inspection of the bend test specimen shall follows. Weld reinforcement be removed prior to bending. The remaining weld should not exceed 1.6 mm. The bend test sample shall be bent until the curvature of the bend test specimen is approximately U-shaped, 180 degree. About visual inspection of the bend test specimen shall shown. No cracks or other weld flaws exceeding 3.2 mm, or one half of the nominal pipe wall thickness, whichever is smaller. In length are present in the weld fusion zone. Cracks that originate from the edges of the bend test area specimen that are less than 6.4 mm in length in any direction should not be cause for rejection. 0.25 inch. Obvious weld flaw is present unless an obvious weld flaw is present. So mandrel location already seen. Bend test is so about 180, or you can say 170. Welder performance qualification. Ability to deposit welds that produce microstructures that are not crack susceptible and to avoid burning through the pressure component of pipeline. By qualifying a welder using setup detailed in mandatory appendix 210.1 and testing requirement outlined in para 210.4.2. The acceptance criteria of NDT examination shall be in accordance with applicable construction code or post-construction code. If the building is done to repair a service-induced defect, the ND method that are used to detect the defect shall be used to verify the removal of defect. When NDA procedures are applied after in-service welding, special procedures may be necessary where the components are operating temperatures significantly above ambient examination time. When hydrogen cracking is a concern, the in-service weld should be examined 24 hours to 72 hours after welding has been completed. Test should be completed in accordance with an applicable construction code or post-construction code. If the hydro testing or hot tapping component after installation is contemplated, the user is advised to consider the temperature of the operating component in order to avoid the test fluid flash to steam. And there is a test sample location in service weld metal buildup welding procedure qualification. Phase bend, side bend, and macro, neck break, MS. What is MS? MS is metallographic test sample. SP is the side bend, F is the face, FB is the face bend. Test sample figure is not to scale. Okay, gentlemen, we'll stop here.